Hello, this is Math Kimchi, and today I will be working on a program that finds the area of polygons. To start off, I will work on a program that finds the area of a triangle, and the way we find the area of this triangle is going to be a little more simplified, I guess, uh, than what we'll be doing later. But anyways, what we first need to know are the coordinates of the triangle. And so let's say it was x1, y1, x2, y2, and x3, y3. And for a triangle, the order in which you label it, like 1, 2, 3, doesn't actually matter. Well, it kind of does, but not really. So, if we knew this, the area would be equal to the half of the absolute value of the determinant of x1, y1, 1, x2, y2, 1, and x3, y3, 1. And the reason why the order that we call points 1, 2, and 3 matters is because depending on that order, the absolute value might, or the determinant of this matrix, this matrix, might be either positive or negative, but it doesn't actually affect our results because you're going to be using an absolute value anyways. And something funny, I guess, is that we are dealing with determinants, but we're also using absolute values, so it's kind of hard to differentiate between which one's which if we were to use, for example, this notation. So I will just be using ABS, which is short for absolute value, and DET, which is short for the determinant of. But anyways, now that we know how to do it, let's get. So let's start out by making a function called triangle area. Yes, and it's gonna be hard to decide how to take the input, because we can either do it as a matrix where it's like m equals x1, or actually double brackets, I'm pretty sure. Yep. So it can be x1, y1, y1, and then you can have x x2, y2, and finally x3, y3. This is one way we can do it, or we can just ask, since we already know that it's going to be a triangle, we can have like six different what was I saying? Yeah, we can have six different numbers, and each can be like one, 1, 2, 3, 4, 5, 6. Or we can just have a list of coordinates, but I guess this it's basically that. Or maybe we can have the function actually ask for inputs, and it could ask like what is the first coordinate, and then, or maybe it could ask like what is the x value of the first coordinate. And yeah, I think we should go with one where we ask for inputs, and yeah. So first, I guess we should make a function called def ask for coordinates, and I don't think I have this here, but wait, I might have used something like this in the regression one. Let's see. Yeah, I'm pretty sure we can just use this code. But I don't remember what it did. Or like, I remember what it did, but I don't remember exactly what it did. So I guess we can say chords equals put to coordinates. We can have inputs equals none. Wait, we don't need that. And then we can just print chords. All right. Let's see. So it should ask for coordinates, and right, so as I'm looking over this, I'm pretty sure we have to say all of the x values and then say all of the y values. So if we go like 1, 2, 3, 4, 5, 6, and then once we're done, we can just press enter without typing anything, and the coordinates should be 1, 4, 2, 5, 3, 6, 1, 4, 2, 5, 3, 6, and I don't know, let's see. I think that it would be easier, since we're working with like actual coordinate points rather than just like statistics, I guess. It would be better if instead of saying all the x's then all the y's, we can go like 1, 4, 5, or 1, 4, 2, 5, 3, 6. So it would ask like yeah, so the things we would input would be x1, y1, x2, y2, and then x3, x3, no, skip that, and y3. But what it's currently doing is x1, x2, x3, and then y1, y2, y3. So I mean, I guess this part could be the same, but maybe we can change I and I don't know. So, I think the first thing we should change is what it asks. Maybe we can make it first ask what is the y, or what is the x value, and then what is the y value. And yeah, I guess that would work. So, you know what, I'm actually just gonna start all over again. So first we can have inputs, if inputs equals none, x equals input, what should the x value be, and then y equals input, what should the y value be. Actually, if it's possible, and actually I'm just gonna, I don't think I'll be using this or like passing like lists into this, so it's not gonna take in anything at all, and we can just say we can make inputs equals I guess an empty list for now, or we can actually call it coordinates or chords for short. What should and I want this to say what should x1 be, like x2, x3, and oh god, I think I forgot how to do it, because one way we can do it is like plus, we can have length chords, or no, it should be a string chord, and we should add +1, because when it's empty we wanted to ask x1 when it has like one thing, we wanted to ask for x2. But the problem with this is that Okay, you guys will see when I run it. Okay. Actually, never mind. I thought that there was gonna be spaces in between here and also in between one and the space, but apparently not. So I guess we can just have this again. And all right, so now first of all, this should be in like a while something loop, while, let's see what we did here, cont. All right, so cont is just a variable that we are creating, and we should set it to true. Continue it equals true for now, but once we get like y is an empty number, then we can say yeah, once we get an empty string for y, we can say that cont equals false. So first let's have I guess the first thing we should do is no, actually we should check if x is empty. Yeah, and we should do that here. Yeah, because it's gonna be like x1, y1, and if they just stop there, it would be here, and this would be the place for x2. So the empty string would be in the place of x2. All right. So if x equals just an empty string, cont equals false, and this should actually be an else, because if we know that x isn't an input, then we're gonna know that y is, like, we don't have to ask for y anymore. And now we can just add so now we know that the coordinate, and this should all be in a else in the else statement, and say chord equals a list, and we can have it x and y, but actually we have to make, currently x and y are both strings, so we have to make them floats, which are basically just integers, or int, but they don't have to be integers, like it can be decimal. And cont, or wait, yeah, we just have to add chord to chords, and I think I did say this before, but dot append is twice as faster as doing plus equals. So, but that's not really gonna matter, but I guess it's just a useful habit. But anyways, that should be it for input to coordinates. Now we just have to say return chords. Now let's run it. What should x1 be? Let's see. We can make it. Let's go simple. Oh, also, it should create spaces at the end. Let's restart this function. One, two, three, four. Yep. So now for our let's see. In our triangle area, we can, instead of asking for we should have chords, but just set it equal to none. And let's say if chords equals none, then we just ask chords equals input to coordinates. Yep, and then we can ask if so now we just need a matrix and it's actually already in a matrix form. Chords is already in a matrix form, but we have to add ones to the end of each of them. And before we do anything, let's just check that chords, if chords, you should just check that the dimensions are good. So dimension chords equals the amount of rows is height width. Yeah, so we can just go like if dimension chords equals 3 by 2. Shoot. So this just means unequal to, and you actually have to do this. So we first check if the 0th dimension of chords, which is just the height, equals 3 or is not equal to 3, or dimension chords 1 equal to 2, then we could say error. We have to print error. matrix should be 3 by 2. Right. No, should it be 2 by 3? Oh god, I don't remember which, if we say height first or width first. I mean, it makes sense to call it 2 by 3s. For example, M3 would be a 2 by 3. Yeah. Right? I'm pretty sure it should be. So anyways, now we just have to make them into 3 by 3s by adding a 1 at the end of each. So I'm gonna ask M equals chords, and oh yeah, we're just adding, so we can go over each row in M. And actually, we don't have to do all this. You could have just called everything M from the very beginning for row in M. And for every row in M, we just do row dot append 1. And let's just see if this actually works. Return M. So and actually let's do print area, triangle area, and let's not give it anything. So x1, let's call it 2, 3, 4, 5, 6, 7. And so it should be 2, 3, 1, 4, 5, 1, 6, 7, 1. 2, 3, 1, 4, 5, 1, 6, 7, 1. Yep. And I'm just gonna call this 1.0 to keep it consistent so that everything is afloat. And now let's see what happens if we make it like not a 3 by 3 matrix. 1, 2, 3, 4. Oh wait, it's saying that there is an error, but we forgot to stop the program. You can say pass. That should work. Or no. Or we can say return. I'm pretty sure pass is the same thing as return. Except, you know, pass doesn't return anything. 1, 2, 3, 4. Alright, so I don't think pass can stop an entire function. So let's try it like this. And I forgot, I don't think we need, we don't actually need parentheses in here. x1, 1, 2, 3, 4. Yep, and it says none. So now we can have oh wait, before we do that, let's also check if wait, we can't actually do that like this. Let's give triangle area a 3x3 matrix. That would be M6. Yep. So that's working perfectly. Now we can have actually first of all, I'm just gonna change this because that makes more sense in my head. You know what, let's say matrix should be alright, before we actually do anything, I just noticed this. I don't remember importing this. That's weird, because I've actually gotten a random like import at the beginning of another Python project I was working on. This one at the very top, I got this thing. It's really weird. I don't think it's a virus because it's like importing different things, and it also didn't import to all of my projects. Let's see if this one, this program also has a random import. No, for these ones, all the imports were, I made all the imports, but anyways, just gonna get rid of this since it doesn't seem to be doing anything. And yeah, now back to triangle area. We can change the dimensions to be error matrix. It should be 3 high and 2 wide, or 3 tall and 2 wide. It doesn't really matter. And for row and M, row dot append 1.0. Yep. And now we just it's actually pretty simple from here. We do ABS absolute value of, where is it? Oh god. Oh, it's just DET M and then divided by 2, and we just have to return area. Let's see if this, oh, you have to make this, you know what, let's just give it nothing for now. What should x1 be? Let's see, let's make it past 0, 0 and 3, 4 and I don't know, like 6, 3. 7.5 is what the program is saying the area is, and we can actually confirm this by going to GeoGebra, or confirm or say that the program's wrong. So we can have our first point be 0, 0, and then 3, 4, 3, comma, oops, I have to move here, 3, comma, 4, then what did he say, 6, comma, 3, and something we can do is to like, wait, how do you do this? Oh, I think you have to create a shape first. There should be something for shapes. Polygon A, B, C, A. And the area of this indeed is 7.5. And something else pretty cool is that this also, what we have also works if we give it points to a line. And actually, let's make it a little more complicated than this. Oops. Let's give it a line like this. So the area of this is going to be 0. And we can see that here. I don't know if this will even work, but if you have this and find the area of this, I guess it doesn't even work. Let's copy this. And we can have area of D, E, F equals T1. T1? Oh. I guess we can say T, or yeah, T2. Yeah, and it's kind of weird because it's displaying it here, but the text is showing everything for this triangle. It's not really a triangle, it's just a segment really, but it does say that the area is 0, and this equation, our equation here, should also give 0 if we do this. So x1 0, 4, 2, 5, 6, 7. 0, 4, 2, 5, 6, 7. Yep, and our area here is 0.0. So that's all cool. And I guess now we can get on to the some more complicated shapes. So the way we are going to find the areas of polygons is by using something called the shoelace theorem, and this is article explaining it, and basically the shoelace theorem says that the area of a shape, if these were the coordinates, you can get the area by finding this times this, plus this times this, plus this times this, and by basically adding all of the diagonal, once you lay out all of the coordinates in order, and also you have to add x1, y1 at the very end. Again, oops. Because I guess then if you don't have that, then you still have to like multiply this and this together, but it's just easier to visualize if you just add x1, y1 to the end. So you add all of the products when you like multiply going down right diagonally, and after that you find the sum of everything by going down left, and you basically do like this minus this. So the product when you add all of, or the sum when you add all of the products of this, and you subtract that by when you add going this way, or when you multiply going this way, and this over 2 will be the area, is basically what it's saying. And another way we can visualize this is by going, well, this, if we ignore everything, and let's say we just have x1, y1, x2, y2, well, we'll have to do this and this, and that's basically how you find a determinant. And oh, by the way, when you do this minus this over 2, I forgot to mention that you need to put these in absolute values because it might be negative. And yeah, so if you do x1 times y2 minus x2 times y1, that's literally the determinant of this matrix. And you can say that about these two as well, and you know, you can keep on doing that. So you can say, oops, if area is equal to this equation, we can also say that it's equal to equals, and well, how art of problem solving puts it is this is just summation, and it's like 1/2 the determinant of I guess we should use ABS, and then determinant Yeah. And this would be like x n y n, and then x n plus 1 y n plus 1. Yep, that's kind of hard to, it's kind of clunky, but I think you guys get the point. So basically what that means for us is we have to divide, well, first we have this giant matrix, and we can either store it this way, or we can just store it by adding x1, y1 to the very end. And it's probably better to just store it with no duplications. So yeah, and once, if we call this, oops, if we say that this is equal to m equals m, then we basically find the area of the polygon inside M by just dividing M into smaller 2x2 matrices and adding the determinants of all of them. Oh, and when we get to xn, yn, we have to do x1 plus, we have to have x1, y1 at the very end. So yeah, let's get going. Let's call this def poly area, and m equals none. It's for now. And so maybe I should call this try area. And first we can say that let's just see that if of m, and we actually only care about the, what is it, matrix, or we only care about the width. We just need to make sure that it's 2. So if it's not 2, print error. Matrix should just have, maybe you can say like coordinates should be 2-dimensional. And we actually should also check if of m is less than 3, or I think it would be possible with 2, because the area is just gonna be 0. So if it's less than 2, aka if it's either 1 or 0, then print error must have at least 2 points, 2 coordinate points. Yep, and for both of these we can just return and next we do area equals 0, and all we really have to do is go through every single possible 2 matrix and add that to area. Or actually we can call that sum of and you can just do for I don't know what I should call it. You can call it like I really can't think of a good name, so I'm just gonna call it I, and we can say for I in range we can use dimension, but I'm just gonna use len of m if equals, wait, oh, what am I doing? All we have to do is do sum that plus equals the determinant of, or first let's do small matrix or S sub m. So sub m or sub matrix can be called or sub matrix should be this would be, for this I would be equal to 1, and this is, alright, so sub m equals this sub m dot append m I append m I plus 1, but actually if we get to the very last one we have to start all over again to 0, so it should be like, I forgot how to do this, but I'm pretty sure. So let's say that there were 10 coordinates and you want, if we have anything less than, if we have I1 or I plus 1 is equal to anything less than 10, then we want it to just, if I plus 1 is less than length m, return I plus 1. Yep, and this is just like pseudocode. And but if I plus 1 is equal to this, return 0. Yep. So let's see. Let's just experiment, because I know that the question mark is, or no, I'm pretty sure it's the percent. So the percent does modulars, and that just means that it gives you the quotient if you divide 10 by, for example, 4, or no, it gives you the remainder, but I'm not sure which one is which. So if we have like 11 and then 10, we should have, or 10, we should have 0. But if we have like 9%, 10, we should have 9. Alright, 8%, 10. So, yep, and let's just see, 0%, 10. Well, this actually isn't ever gonna happen because I is always gonna be 0 or above. But so yeah, I think we found our solution. So we need I plus 1 first, and then we have %10. But if you're curious what would happen if we accidentally flip the orders around, this is gonna remain the same, but if we do this, we should get 1. Yep. 2, 3, 4, but then we should get 0 again. And then we should get I don't know, 2, 1, 0, 0, and we might get an error on this. Yep. Because we're basically seeing the remainder we get when we divide 10 by 0, but that's like, you know, we can't divide by 0, so we get an error. But anyways, they should now sub m should work now, and once we add some that are determinate, we just have to return the absolute value of sum det divided by 2. Let's see. Oh, shoot. We should not run this. Well, we have Python up. Alright. Oh, I forgot to actually run our function. Poly print poly area. And let's give it nothing. Wait. Oh, we we first have to do if m equals none, m equals input. Yep. Alright, so what should x1 be? Let's call it, or let's see. Oh, is there no way to delete everything? So let's say, let's make some points. 0, and let's actually go to the negatives for some. Alright, let's just plop down some random points. Alright, and then our shape could be A, B, C, D, F, G, H, I, A. Alright, this is gonna be annoying to do. Alright, so it's 0, 0, -3, -2, -2, -4, x4, -1, -2, -1, -3, 3, 6, 3, -2, and then 4, 2, 2, 1, 3, -1, 2. Oh, shoot. Dimension. Wait, where is this? Oh god, we forgot to make this 0, and now we have to type all that in again. God. Actually, yeah, I should have done this. I should have done this first, but it's gonna be easier now because we know we already have everything correctly. -3, -2, -2, -4, -1, -2, 1, -3, 3, -2, 4, 2, 1, 3, -1, 2. Right. And we should copy this. And now we can do poly area, but actually I'm gonna put this here. Polygon 1 P1 equals I'm not sure if this is better or if it's better. Yeah, but I'm not sure if it's cleaner to do it this way or have them all lined up horizontally, but I think I like this better. So P1 is our polygon, so we just have to give poly area P1, and all right, error, list index out of range. So I'm just gonna do this. List index out of range. I'm just gonna make it print I guess we should make it print like, I'm just gonna make it print I is plus string I. Yep. 8, 9. All right, now I'm gonna make it print M is shoot plus star wait, so 9. Oh, why did I make this 10? It's because the example. Oh god, I should have made this just len of m. And the bad thing is that if you were just if we just have one more point, if oh shoot. Alright, something's wrong with this, but I'm not gonna worry about it. If we just have one more point in our P1, then we wouldn't have caught that mistake, because the length of M would have been 10, but it should work now. 24.5 is our area, according to this, and I'm pretty sure this is supposed to be the area. Let's see. Area 24.5. Yeah, and actually, something else. Oh, cancel. Oh god, I'm just gonna reload this. What was I gonna say? Oh, yeah, for the triangles area, the order didn't actually matter, but for polygons, the order in which we call the points actually will matter. So if you have, for example, A, B, C, D, all right, and the if we do it correctly, our, where is this? Our polygon would be A, B, C, D, A. And, you know, there's nothing wrong with that. It's just normal. Oops. Yeah. But if we just have this polygon here, ABC, oop, oh god, what is this? So A, B, C, D, A, and we just come up with the area for it. Yep, the area is 12. I'm sure we're gonna get the same thing if we put it here. So -3, 3, 2, -2. And 2, 0. Yep, we got 12.0 as our answer. But what if instead of putting our points A, B, C, D, we have another order? Like we put it in a different order. Also, we don't need this anymore because we already solved the problem. So let's say we did A, C, D, B. All right. So we would still have A, -3, -3. But if we have a C, which is 1, 1, D, -2, 0. Where's this point? B, 2, -2, 2, -2. We get 3. And the reason why is because when we do that, our polygon isn't actually this polygon. What we have is a shape that's a little different. Like the vertices are still the same, but it's actually gonna look like A, C, D, B, A. It's gonna be this weird sand clock. Yeah, it's gonna be like a weird sand clock shape. And so, what the heck? Oops. Oof. Yeah. And the area of this is 3. So that's why we can't do like we always want to like visualize it and put it in the correct order. In this case, it would be A, B, C, D. But actually, as long as like the relative order is good, as long as like this doesn't happen, we can have something like C, B, A, D, and then that would be the same thing as A, B, C, D, because in C, B, A, D, we see that the lines or the segments of the polygon are still equal as ABCD. So CBAD. Let's try that, and we should get the same area since the shape is essentially the same thing. So 1 1 2 -2 and -3 -3 and then it's -2 0. Yep, and we still get the same area. We don't want that. Yeah, but in triangles, that's not really a problem. If we just had ABC, you know, it's gonna be the same triangle no matter what. ABC or ACB or CAB. You get the gist of what I'm saying. But anyways, finding the area of triangles and polygons are just one of the many uses of determinants and just matrices in general. And that's about it for this video.